Okay, we're going to have the world's quickest introduction to Magic, the layout tool, which is similar to Siliwiz, except more precise and more powerful. Um, as a consequence, harder to use. So open up a terminal and change directory into voltage divider. Whoop. Spelled it wrong. Better to use wildcards. Okay, so last time we were working with the simulation tool. Now we have to actually make the part. So change directory into mag. I'm going to list it out. And there should be some tickle files in there uh, that we'll use. And this is the setup file that will control how Magic behaves. So let's start Magic by typing that in. RC file, and then the name of the RC file, which I'm going to use wildcards. So it should start up in the Skywater 130 nanometer PDK. And it does. Now, what I'd like you to do first is just to play with it a little bit before we get started. So let's set the grid to 1. And then if we do Control Z, that zooms in. Z. Shift Z zooms out. Okay. And Z zooms in. So the way to draw things is I'm going to call out what I'm doing with the mouse button. But this is the left click and then right click, and that makes the full box. I'm going to make it even a little bit easier for myself and snap to grid. So if I try to do left click here, well, it's making a liar out of me. Anyway, there's a box. Then you paint it by pressing the middle mouse button. Okay, where in other tools you might choose what you're drawing and then it draws whatever you want. We do it. Magic does it the other way. Okay, so U is undo. Right, so useful command, and you can follow along. You don't have to. I really would like it to snap to grid. Okay, so and we'll paint it polysilicon. Now, if we hover and press S, that should be selected. And then if we want to copy, it'll copy that corner to that corner. Okay, just by pressing the letter C. Okay, now if I select that and then I want to move it, it'll move it in much the same way. And I'm just moving it around. Now something happened while I was moving it. So what I want to do is zoom in on it. So left click, right right click, Control Z, and now you can see there's a DRC errors. There's two, right? What are they? Well, we can do DRC and it will tell us. And the polysilicon is too close. All right. Now it kind of zoomed in. The letter V will zoom full extents. All right, so Z zooms in, Shift Z zooms out, and the letter V zooms full extent. Now, if you're looking at that cross here and see how it's across, right? Sometimes you accidentally press the space bar and the tool will change. So in order to draw a box, you need to have that cursor. Do most things, you need to have that cursor. Okay, but there is something that you can do in that cursor. Is I hover in here, right? And I just left click, and now it draws a path. And to get it to stop, you just right click. So again, I hover in here, select it, left click, and then right click to stop. Okay. Now let's say I want to move things around. I can't. I have to keep hitting the space bar. Now I can select certain things and move them around. Now, this is something for you Cadence users out there that might surprise you. I'm going to move this box right here. Okay, I'm going to select something else. So that looks like it's kind of continuous, right? Well, let me select it again and then move it and see how it cut that. Okay, so I didn't erase it. But what happened is I Magic will, if layers, it doesn't keep track of the polygons, it keeps track of stitches. And so by having this, what you might think of as a weird behavior, allows the design rule checking to happen real time. So let me, do that again. As I'll do a move. I'm trying to move that. So I'm trying to get a DRC error now. So I'm going to turn snap to grid off. There, I got the corners to touch. Now this is a small thing, so it doesn't take that long. When you're working with like a whole mass set, you got to turn that off. It'll choke your computer. Better to do it hierarchically. Okay. So I can select that and left click, middle click, and turn it to metal 1. Okay. So we're pretty much going to use metal 1 today. So we can just, and then if I select delete, select delete, select delete. Okay. So I'm just pressing S and deleting. I hover inside, S, delete. See, it combined that polygon. Now, um, I want to create the two resistors. Luckily, they have a procedure that will create the resistors for you. So if you go to device 2 and you have a lot of choices of resistor, I'm going to use this one, poly resistor here. Okay. And if you recall, we had 10 microns long, 0.33 wide. I don't want a guard ring. Everything else is fine. And we can create. Okay. So that's kind of a long, skinny thing. So I'm going to V, now I can see it better. But I want to make a copy. Now, in Magic, when you can see the layers underneath, you can edit them. That can cause you a bit of havoc. Okay. So what I'm going to do is set the grid. I'm going to set the grid to 0.5 micron. And I'm going to put, I'll leave it there. Okay. So in order to more easily, so if I start selecting things, I want to copy the whole thing, right? I have to, it's giving me all that. So I kind of need to go up one layer of abstraction. So if I don't hover over anything and I just select, it selects everything. Then Shift X, now it's a cell. And I can copy. So I'm going to put the cursor here. And that didn't really copy because I needed to select it, which is hover S. Okay. Now I want to see, make sure I've done that properly. I'm going to kind of select everything, X. Now I've descended and I can see everything. All right. But actually can cause some difficulty. So I'm going to do Shift X and now I'm seeing the cells. Okay. So I want to make it easy on myself and be able to connect to Metal 1. So what I'm going to do is just draw. You can see that feature there. I'm just going to draw a box around it and paint it Metal 1. Then I'm going to hover in that box, but not where the resistor is, off to the side. I've selected it. Then I'll come down here where I want it to be. Copy, copy, copy. Because I want the current to flow in here. Then I want it to come up here and flow out here. Okay. So now I could do boxes to get up here, but we can do a path, right? So I press the space bar. I select that, click, and now I should be drawing in Metal 1. I'm drawing this a lot bigger than it needs to be so that I don't run into trouble later. And I'm going to hit the space bar. Oop, went too far. Now I've got the cursor. Okay, great. Now I can use X, select everything, X, and you can see that everything is connected. Shift X brings me up here. Now I want to put some labels or ports on that so that Spice can find out where things are going to go. So I select it, and there's a nice tool here in this kit where I add text and the text string. You got to make sure you have the right name. Leave everything else the same, attached to layer default, but then you're going to make a port. Now, 1 micron is actually too high, you'll see. But if I put 0.5 micron, the letters should fit inside. Okay, they don't, but it's good enough. Okay, now I'm going to come over here and label it VSS, port enable. Actually, I'm going to cancel VSS, apply. Then I'm going to select here. Out. Now I probably should have done this earlier, but let's save it. And we got to be careful with how we're saving it. But voltage divider, it'll give it the extension magic. And for this case, best to use auto rate. Okay, so now we should be something. Let me just select that. I'm hovering over here, pressing S until everything is selected, then pressing X, and see no DRC errors. So rather than DRC being a separate step, at least at this level of design, it's happening practically instantaneously. Okay, so that's an advantage because as soon as you see a mistake, it pops up. So in a way, better to learn, I think. Okay, so what we want to do is now extract this circuit spice parameters so that we can compare it to what we did um, in simulation to make sure it's actually the same. All right. So now there's a lot of commands here, so it's actually better to load the tickle commands in directly. So load file, extract for LVS, and it will do it for you. Okay. Let's just double check what those are. Okay. So it has two, and these are all magic commands: extract, extract LVS, sets it up for LVS, but then there's some things you have to turn off. Subcircuit hierarchy, right? And then and then extract to spice makes this file, okay? Because when I just said extract to spice, it names it what you called your file, okay? And so this is a spice deck. So we have RO from out to VSS, and that is the name of the resistor, and that's the width and the length. And then R1 is from VD to out. So that should be good to go. So now we want to run the layout versus schematic. And I'm actually going to get out of that. Now, let's go up one directory, go into X, and then Xschem. And let's open, this is where our files reside. And we actually want our voltage divider schematic. So this is what We have VDD, VSS out, two resistances, right? Is that the same as our layout? But it checks a spice file. So the only way to do that is you actually have to netlist this. It happens automatically when you do the simulation, but when it's time for LVS, you have to do this. And if we click show netlist after netlist command, it pops up. So we have IO pin, VDD, VSS, R1, R2. But see, actually, you could. This is so easy. You could do it by eye. Okay. So now we'll get rid of that. So now we're going to run another program. LVS netgen tickle. It's not really a tickle file. But anyway, netgen is a file that will compare LVS. This is the file that was generated from Magic because you're in that directory. Dot dot means go up one directory, then go in here, go in here, go in here. And that's the one we just created from Xschem. And you need this file to make sure it knows what Skywater is. So if you were to do a different file, you would, change the names of these and maybe even the locations. Okay, but that's a lot to remember and to have to type in by hand. And you can do much better scripts than that. Okay, so now that's not really a tickle script, it's a cell script. So all I have to do is do source, meaning run, and where did I put it? Oh, I'm in the wrong directory. So cd back to mag. So source, that's the present working directory, LVS netgen.tickle. I'll just type it LVS underscore netgen dot tickle, and netgen should come up. Okay, and so this is a little easier to understand down here. Circuit 1 contains one device. Circuit 2 contains one. Circuit 1 has two nets. Circuit 2 has two nets. Final results, circuits match uniquely. Now, there is a lot more to layout versus schematic than this, but let me tell you, when you see this phrase right here, you are the happiest person in the world. I'll just tell you that. Okay, so um, in the previous tutorial, we made a schematic of a voltage divider, simulated it, and it worked. We just laid out our voltage divider, extracted it, and passed LVS. Okay, so now what we want to do is extract that voltage divider again, but in a format that actually Spice can understand. So let's do it again. So let's open up Magic. Um, and we'll open our file. Okay, there we have it. So now it's just what you want to do is this doesn't need a file, but you just extract. Okay, cell sky, it says things have been extracted. Great. Now we should just be able to type x2 spice finished. Now let's go and see. Is this what, you know, maybe it would have been better to name it something else, but let's just look at it. And that's not quite what we want. So I'll do X2 Spice LVS, that sets it. And let's see if that's what we get. Okay, so we have sub-circuits and things like that. All right. So we have, this is the file now that we want to simulate, but we need to know where that file is. So we do present working directory. And I'll tell you why later, but I'm going to highlight that and copy it. Now we're going back to Xschem. Xschem voltage divider SH. Nope, wrong one. I wanted the test bench. Voltage divider test bench. Okay. So I'm going to copy that so I don't have to retype it. What it is I had just done the solution. Okay. So when you open your file, I'm just deleting these. Okay. So this is my old simulation, right? Now I want to simulate the extracted circuit. So actually what I can do is just copy, okay, and double click. So what you do is say schematic voltage divider, and we'll just call it EXT. You give it a new name as long as it's not something that already exists. And then you remember I said, oh, copy the name of that directory. You put it right there. You got to make sure. Oh, yeah, you open it with double quotes and it. Okay. Now, notice that when I copied it, it's out and out. It shorts those two pins. So I got to double click out and call it out too. Then over here in simulation, this is what you would have seen, right? And then you add out two. Right now it'll automatically plot both. Okay. So notice that when I changed that schematic name, it went from the symbol went from voltage divider to voltage divider extracted. Okay, that's different. Now, something I had done was put in a pulse from the last time it was just a DC. So we should be able to, let's go to show netlist after netlist command. That way you can see what's going on. Netlist. And here's the, we have voltage divider extracted. Include all these files. That's the control. And we should see voltage divider symbol. That's the original one. Voltage divider extracted. That's that one. Okay. So now when we simulate, please don't make a liar of me. Okay. So now we have pulses. And so we have out 2 and VDD. And so they're exactly over each other. They're perfect copies, which isn't usually the case. It's just the parasitic capacitance that was extracted for this was so small that it didn't affect the circuit. If you want like a feel for it, right? I could just fake it with a bigger capacitance there, right? Netlist, simulate. Sometimes I have to click it twice. Okay, so now you can see the node that has capacitance on it is a little bit slower. Okay, so that's if you don't get pulses, if all you see is solid, value equals 3, that's what you had originally. And you'll find since it's DC, effectively, out 2 and out overlap each other, so you can't see them. Okay. Now, yeah, what if you wanted a pulse? Okay, easy enough. But you have to put things in double quotes, and the keyword is pulse. And you have the first value, 0, second value, 3, third value, delay, next value, rise time, fall time. I forget what I had, but that would be on, and that would be period. You would have to netlist again. Let her rip. Okay. So that's pretty much it. A complete design flow. So your job is to repeat it. Okay.